In the previous hands-on demo, when I tried to pause the cluster, Redshift was not allowing me to pause the cluster because it wanted a snapshot. Elastic resizing is also not allowed if you do not have a snapshot of your cluster. So these are feature related, but snapshot or backup are very important for any database for that matter, be it operational data stores or data warehouse systems. Now, why do we need snapshots or why do we need backups? Because if something goes wrong to your data or your database, you have a place to fall back to. Meaning, if you take a backup of your, let's say, Redshift cluster, what will happen is that your entire data would be stored somewhere else. Now, if something happens to your Redshift cluster, so let's say someone deletes it, or the data gets corrupted, or the availability zone goes down, or let's say the region goes down, in that case, you can use that snapshot or you can use that backup to restore the cluster to the state when the snapshot was taken. So this is the importance of snapshot and backup, and it is very, very important. We should always have a snapshot and backup policy for our production and pre-prod environment at least. Sometimes we take backups of dev environments also because we do not want to lose that environment. Now, how snapshot and backup are taken in Redshift, I'll show you that in the hands-on demo of this particular part. But before that, how snapshot works in Redshift. So the first thing is there are two types of snapshots. One is automated snapshot and the other one is manual snapshot. And snapshot and backup are actually the same thing. These are not two different things. So I can also say that there are two types of backups in Redshift. One is automated backup and the other one is manual backup. Whenever we take a snapshot, those are stored in S3 by default. So as you know that S3 is highly durable and highly available, we do not lose the file or the snapshot file or the backup file that is stored in S3. Now this is important. What happens is that if you enable automated backups, Redshift takes incremental snapshots that track changes in the cluster since the previous automated snapshot. So let's say I enable the snapshot today. For the first time, Redshift would take a full snapshot. The next time onwards, so let's say the automated snapshot again happens tomorrow. Tomorrow's snapshot size would be much smaller than today's because today's would be full snapshot and tomorrow's snapshot would contain only the changes that have happened to the data. So let's say your total Redshift data size is 200 GB and you have enabled the automated snapshot today. So today's snapshot size would be 200 GB approximately. And let's say from today to tomorrow, you make approximately 20 GB of changes. And tomorrow's snapshot would contain only those 20 GB changes, not the 200 GB. So that's why the snapshots are incremental. Now, when these incremental snapshots are taken at every 5 hours or every 5 GB per node, data changes. Again, if I pull up the example that I've just talked about, you have 200 GB of data. You take the snapshot today. So today's snapshot size would be approximately 200 GB. And you make 20 GB of changes. And let's say we are using only one node. So in that case, the incremental snapshot would be taken 4 times because the snapshot happens at every 8 hours or every 5 GB per node of data changes. Now the data change is not dependent on the time, meaning let's say 20 GB of data change happens only at 10 p.m. today and the change happens over a period of 2 hours. The incremental snapshot would be triggered 4 times during those 2 hours. There's one more thing, one more concept that you have to understand is once you restore the snapshot to a new cluster, a concept called lazy loading comes into picture. Meaning that the data would not be loaded or the data blocks would not be loaded directly from S3 to your local storage. It will be done later on. So I'll talk about it in the next slide. We also have manual snapshots. So manual snapshots are something that we trigger. So we go to a cluster, click on the actions, and then when you click on create snapshot, it creates a manual snapshot. We can also choose tables that can be excluded from the snapshot. So let's say out of 200 GB, only 120 GB of data are very critical. Remaining 80 GB are not critical. So those 80 GB are in, let's say, 4 tables. We can exclude those 4 tables from the snapshots. So in that case, my snapshot size, the full snapshot size would be 120 GB, and the changes of only those tables would be captured in the automated snapshot. So the tables which are excluded from the snapshot, changes to those tables will not trigger incremental snapshot as well. We can also automatically copy snapshot from one region to another region. Let's say we take a snapshot or a backup or automated snapshot or manual snapshot in North Virginia region. For disaster recovery, we want those snapshots to be available in, let's say, Ohio region. So we can enable automatic copy of snapshots across another region. In our case, maybe from North Virginia to Ohio. It can happen anywhere in the world, any AWS region. You can choose any AWS region as target region also. So what is lazy loading that I have talked about? So let's say this is the snapshot on S3. I have taken a snapshot of my existing cluster and I restored this snapshot to a Redshift cluster. Now the cluster is available before all data is loaded in the cluster. What happens in lazy loading is that it streams data on demand from the snapshot in response to active queries. As you already know that Redshift contains 1 MB of blocks, and let's say the snapshot would contain all these 1 MB blocks. So in our case, it is 12 blocks only: yellow blocks, green, gray, blue, orange, and black blocks. So these are the Redshift blocks that have been backed up to S3. Now what happens is that, what is the meaning of this second point? Streams data on demand from the snapshot in response to active queries. Now let's say I run a query from a table of yellow and green box. So what will happen whenever I run the query on that table, only then those blocks would be made available in the cluster from snapshot which is there on S3. So whenever you run the query, these blocks would be pulled from snapshot to the cluster, and then the result would be made available to the endpoint. There might be a question that wouldn't it increase the latency? The answer is yes. For all the tables, queries that you run on them for the first time will have higher latency. So you can actually avoid that by running a select star on all the tables before making the cluster available to the application or in customer. In case of lazy loading, the remaining data would be loaded in the background automatically in its own time. So it's not that the loading would not happen. So the loading would happen block by block parallelly from snapshot to S3 in the background. Let's do a small hands-on on snapshots. As I had paused the cluster earlier, it is in paused state. I'll have to resume the cluster again so that I can create a snapshot. So if the cluster is paused, I cannot take a snapshot. So I'll have to resume it. I'll be resuming right away. It will take some time for the cluster to get restarted or resumed rather. Let me tell you about the snapshot page. So if you click on clusters, we have reserved nodes and snapshots. So if you click on snapshots, so these are the two snapshots that are available right now, and I have taken both of them today. One of them is manual snapshot and the other one is automated snapshot. So if you scroll to the right, it will tell you the type of the snapshot. One is automated and the other one is manual. It also tells you the size of the snapshot. So if you see, this is an automated snapshot which was taken today only, and it is a full snapshot. So the size is 107 MB. So the size of the manual snapshot is also 107 MB. And if you can click here to actually change the type. So either you want to see only manual snapshots or only the automated snapshots. Now one more way you can identify whether a snapshot is automated or not. At the beginning it will have RS, which is basically, it tells you that this snapshot was taken by Redshift automatically. Now I can take snapshot from here. I can click on create snapshot. It will ask you for the clusters that are available, and I'll have to provide the cluster for which I want to take the snapshot. Now right now the cluster is not available because I have resumed the cluster. It will take some time. You'll mention it, then you mention the name of the snapshot, and you want to also mention the retention period. So whether I want to keep it for 1 day, 7 days, or some custom value, I'll keep it as 1 day. And if I click on create snapshot, it will be created. I will pause the video and come back when my cluster is available. The current state of my cluster, if you see, it is modifying, and essentially it is resuming the cluster. Okay, so the cluster is in available state. I can click on this and I can take the snapshot from here also. So if you see, I have this option of create snapshot in backup and disaster recovery. I can click on create snapshot and I'll have to mention a name, RS manual snapshot 2, and I want to keep it for 1 day. Click on create snapshot and it will be created in the background. Similarly, I can go to snapshots here and click on create snapshot. So before that, if you see, the second snapshot is getting created. Click on create snapshot and mention the cluster identifier, which is data engineering on AWS Redshift cluster. The name of the snapshot is RS manual snapshot 3, and I want to keep it for 1 day. Click on create snapshot and the third would also be created only when the second one is done. So you cannot create a snapshot because when another snapshot is ongoing, it is not possible. Either it is manual or automated. So if an automated snapshot is in progress, you cannot create a manual snapshot. And I cannot show you automated snapshot because that is taken by Redshift automatically based on a schedule on a daily basis. So once this snapshot is done, I will go ahead and create the third snapshot also. But in the meantime, what I can do is that I'll go to the cluster and I'll show you how do you configure automated snapshot copy to another region. So again, this is the cluster and I have this actions button. Here I have configure cross region snapshot. If I click on this, it will say whether you want to copy the snapshots or not. If you mention yes, you'll have to mention a destination region. So you can mention any available destination region that you have. I have mentioned US East 2, and you have to specify for how many days the automated snapshot has to be retained in the destination region. I can mention 1 or anything, I mean any other number from 1 to 35. This is for automated snapshot. If Redshift automatically copies automated snapshot in the destination region, and let's say I mention 7, then what will happen is in US East 2 region that I have mentioned here, the automated snapshots would be retained for 7 days. And let's say for manual snapshot, I mention a custom value, which is, let's say 10 days. So in that case, what will happen? Any manual snapshots that are copied, automatically copied to US East 2 region will be kept for 10 days. So this is how you can configure cross-region snapshot, automatic cross-region snapshot rather, in Redshift. So using this, you can configure Redshift to automatically copy either the automated or the manual snapshots to another AWS region. So in our case, our primary AWS region is North Virginia, and the destination region that I have mentioned is US East 2. So from US East 1 to US East 2. What I have mentioned here is that in the destination region, that is US East 2, I want to retain the automated snapshot for 7 days and I want to retain the manual snapshot for 10 days. So if you click on save, it will be done. I'll not do it, and don't do it for your hands-on also, because this is not needed for hands-on. This is unnecessary because there will be costs associated with it. So it is just for your information. You do not need to do any hands-on for this. Alright, though the manual snapshot is available. Now let me go ahead and create the third manual snapshot using this option. Click on create snapshot and mention the cluster identifier. In our case, it is data engineering on AWS Redshift cluster. And I'll mention a name and I want to store it for 1 day and click on create snapshot. Obviously, the third snapshot would start created. So remember, if you are doing hands-on, please go ahead and delete the snapshots, because you'll be charged for the snapshot storage also. So it does not make sense to keep the snapshot unnecessarily. So please go ahead and delete those whenever you are done. So how to do that? Just select the snapshots. So just select the manual snapshots that you want to delete from this select button and click on delete. So these two manual snapshots would be deleted. So the third manual snapshot has also been created. Of course, I'll go ahead and delete the snapshot, which is this one. And the third manual snapshot also got deleted. So this is how you delete the snapshots. So that's all about the Redshift hands-on. Obviously, go ahead and delete the cluster. So select here on the cluster page, click on actions and delete the cluster. It will ask you for a final snapshot. I do not need that. And type delete, so the cluster would be deleted. I'll be creating clusters again to load data for the next section, to load data and run queries, to create objects, showing you DDL and DML statements. For now, you can go ahead and delete the cluster.